Next you will see the ranking of the 10 most powerful physicists in human history. Number 10, Yang Zhenning is best known to us for his non-conservation of pronouns. But if his contribution was only this, he would definitely not be on the list. Can Yang be ranked among the top 10 greatest physicists? Mainly due to Yang Mills' theory. Although this theory also has contributions from Mills, Mills is only Yang's assistant. The decisive contribution was made by Zhenning Yang. Yang Mills' theory is a gauge field theory based on the SU group. It is also the basic theory in the Standard Model. Based on this theory, physicists not only unified the electromagnetic force and the weak force into the electromagnetic force theory. The quantum chromatic motion theory based on the strong interaction was also established. Among the 4 fundamental forces, in addition to gravity, Yang Mills' theory is used to describe the other 3 fundamental forces. It can be said that the electromechanical theory of example physics. Number 9, Richard Lungman. Lungman's basic path expression and Lungman diagram directly pushed quantum electrodynamics to a new level. In the microscopic world, the movement of examples is probabilistically random. You can be in different positions at the same time. This goes against common sense. The path integral can mathematically reconstruct all possible paths of the example. This makes the quantum behavior of microscopic examples more intuitive. At the same time, in quantum field theory, the essence of the example is a ball of energy. So the transformation and decay between examples are the transformation of different energies. In the process of example transformation, the energy alternation is also intricate. Without Lungman diagrams, physicists would have had a hard time quantifying the details of decay. And with Lungman too, the details of the transformation of microscopic examples seem to be recorded. We can clearly and easily quantify the process and results of example interactions. This is crucial to studying the nature of the example. Nowadays, Lungman's path integral expression and Lungman diagram have become the core framework of modern quantum theory. 8th place, Paul Dirac. Dirac's most important contribution was the Dirac equation. This is the first time that the effects of special relativity have been introduced into quantum mechanics. We know how fast examples move in the microscopic world. So the quality of the example and the time will change depending on the speed. At this time, the relativistic effect of the example becomes very significant. If relativistic effects are not taken into account when quantifying the motion of an example, then the calculated results will be ridiculously wrong. And Dirac brought special relativity into quantum mechanics with the power of one body, laying a solid foundation for the development of quantum electrodynamics. 7th place, Werner Heisenberg. Heisenberg's greatest contribution is the uncertainty principle. This is what we often call the principle of uncertainty. This principle profoundly explains that the position and momentum of microscopic examples cannot be determined at the same time. The more accurately the momentum is measured, the less accurately the position is measured, and vice versa. The reason why we don't use the teaching method of the principle of uncertainty nowadays. It's because physicists discovered that position and momentum cannot be measured at the same time. It is an intrinsic property of microscopic examples and is not caused by experiments. The uncertainty principle allows humans to deeply understand the nature of microscopic examples. As a result, humankind's understanding of quantum mechanics has once again been refreshed. 6th place, Alvin Schrödinger. Schrödinger was a key figure in the development of quantum mechanics. Schrödinger's most infamous cat is undoubtedly Schrödinger's cat. But this is just a metaphor he uses against the powers that be at the University of Copenhagen. Schrödinger's greatest contribution is the Schrödinger equation. That's why Schrödinger is a key figure in quantum mechanics. It's because Schrödinger quantified the fluctuation law of force particles in mathematical form. Only then did quantum mechanics have universal mathematical tools. We know that in the microscopic world, lightons exhibit both lighton properties and wave properties. But essentially, microscopic force particles are waves. And the wave shape of force particles will change with time. Human beings have no idea what to do when faced with this new form of exercise. The clever trick of Schrödinger's equation is that he abandoned the traditional thinking of describing the movement of matter. Since your basic force particle does not have a clear position and shape. Okay, I'll bypass that. Even if the basic force particle is a wave, it always has kinetic energy and fitness. So your kinetic energy plus fitness is your total energy. The kinetic energy and fitness of the basic force particles change with the change of the wave. Therefore, it is necessary to introduce a wave function that fluctuates in kinetic energy and fitness. The wave function of the lighten is represented by the Greek subphopsy. The wave function has a certain value. And this value depends on the state of the forceon. If we could know the wave function of a forceon, then according to the Schrödinger equation, we can know the possibility and energy of finding this force particle at a certain location. Through the Schrödinger equation, we can use the probability quantity to find out the next movement rules of the microscopic force particles. Therefore, Schrödinger's equation is also called Newton's second law of quantum mechanics. Is enough to prove its importance. Fifth, Niels Bohr. Bohr's greatest contribution was the Bohr model of electron orbital defibration and the principle of complementarity. Its mathematical contribution to quantum mechanics may not be outstanding. The reason why Bohr is ranked before Schrödinger. The most important reason is that Bohr created the center of quantum mechanics, the most mainstream Copenhagen school, in the 1920s and 2030s. The development of quantum mechanics is still in the transitional period between the new theory and the new theory. The future is not clear. Intercommunication schools have been fighting for the right to interpret quantum mechanics. The winner in the end was the Copenhagen forces headed by Bohr. This force is also known as the mainstream theory of quantum mechanics. What we have learned so far about quantum mechanics almost all come from the Copenhagen school. For example, quantum entanglement. The mainstream explanations for measuring collapse come from this school of thought. It can be said that Bohr is the founder of the new quantum theory. Its influence still exists today. Fourth place. Max Planck. Planck's substantive contribution to quantum mechanics may not be significant. Even he himself was not optimistic about quantum mechanics at the beginning. Planck could leave behind few contributions. It's Planck's formula and the concept of energy quantum blooms. But it is undeniable. Planck was the pioneer of quantum mechanics. It is precisely because he used the concept of energy quanta to explain black bottom radiation. It was the first time that it subverted Newton's classical mechanics. This is the first time that human beings have transformed the energy continuity thinking of rebirth into discontinuity thinking. This is how quantum mechanics was born. Planck is also the undisputed father of quantum mechanics. Third place. James Maxwell. Maxwell's greatest contribution was the unification of electricity, magnetism, light, and electromagnetic fields, and established Maxwell's equations. This is a unified theory of electromagnetic phenomena. It is also a masterpiece of electromagnetic phenomena. Therefore, based on this theory, human beings begin to use electromagnetic waves as a carrier of communication, laying a solid foundation for the information revolution in the Third Industrial Revolution. Human productivity begins a second explosion. Since electromagnetic phenomena are closely related to human life, therefore, the importance of Maxwell's equations has been elevated to a whole new level. Second place. Albert Einstein. Einstein is very familiar to everyone. The previous physicists were basically within the framework of quantum mechanics. And Einstein is the god who subverted the entire physics world. It can be said that Einstein is the second creator of the entire physics. Einstein's special theory of relativity completely rewrote classical physics. The general theory of relativity completely rewritten Newton's theory of universal gravitation. At the same time, Einstein proposed the photoelectric effect and the secret of EPR in quantum mechanics. He also made significant contributions to the development of quantum mechanics. The two greatest theories in physics today are relativity and quantum mechanics. Einstein is the founder of these two theories. If quantum mechanics is a new and brilliant result, the general theory of relativity is the result of Einstein's personal madness. As a result, humankind's concept of understanding the universe has been completely overturned. Einstein is even the only person who represents the pinnacle of human intelligence. First place, Isaac Newton. Newton can be said to be the most powerful rebel creature on Earth. The well-deserved first person in human history. Newton's contribution to mankind has gone far beyond physics. Its contribution to crisis scores can even be ranked outside the collection of mathematicians. Strictly speaking, there was no systematic science before Newton. Copernicus, Tycho, Kepler, Galileo, and others are still exploring new ways for humans to understand the world. The birth of Newton for the first time incorporated the form of logical deduction into the understanding of the objective world. Newtonian mechanics is not only the beginning of physics but also the beginning of science. As a result, human beings' understanding of the world has leapt from religious theology to rational science. Human productivity begins to explode exponentially. Newton's contribution to all mankind is no less than that of the first time mankind walked upright. From then on, scientific thinking began to shine infinitely in human society.